So we're asked to solve the equation that's given here. We need to get z out of it, and we can see that there's some imaginary numbers scattered through. So when we get z, we need to express that final answer in Cartesian form, which means we have the real and imaginary components separated out. So let's start this off by getting everything on the top line. So I'm going to multiply this up to the right-hand side and this up to the left. So we get z minus 3 plus 2i multiplied by this was coming up, so z plus 3i equals, we've got the z plus 2 and then this is going up, so z minus I. Alright, next I'm going to try and expand out these brackets. So on the left hand side here, z times z is z squared, and then we're going to get 3zi. We've then got negative 3 times z, so negative 3z. Negative 3 times 3i is going to give us negative 9i, and then we have 2i times z, and that's going to give us on the end 6i squared. Alright, so now for the right hand side, expanding this out, we're going to get z times z, which is z squared, z times I, and it's negative, so minus iz. We've got 2 times z, and minus 2i. Alright, so that's a little bit messy. What I can do is see if there's anything that kind of cancels straight up, and the one big one I'm seeing here is that z squared is on the left and z squared is on the right. So these are going to cancel out with each other, and we're not going to need to carry them through. I don't really see anything else here that cancels directly, so what I might do as a next step is gather all the terms that have z's in the left hand side and anything that doesn't have a z on the right hand side. So following through on that, we've got 3zi minus 3z, that's going to go to the other side, plus 2iz, and this is going to go to the other side. And then this one has a z, so I'll swing it over, so it'll be positive, and this one has a z, so swing it over, it's going to go negative. And that one's going to stay put, so let's leave it there. Alright, so anything that didn't have a z is getting over, so we've got plus 9i, and this minus 6i squared. Alright, so let's factorize out the z's. So we're going to get z outside of, it's going to be 3i minus 3 plus 2i plus I minus 2. And over here, I can put these together, so that's going to be 7i. And this I can simplify, because we know that I squared is equal to negative 1. So if we substitute that in, we're going to get negative 6 times negative 1. We can do that right now. So that's going to go to positive 6. Alright, so as for what's in this bracket here, we should be able to make it a bit simpler. So the imaginary parts, we've got 3i plus 2i gives us 5, plus another one gives us 6, so 6i. Oop. Habits. And then we've got negative 3 and negative 2, so overall that gives us negative 5. Alright, so we want to get z on its own, which now is pretty easy. We're going to get this divided by this goes to the bottom line, so 7i plus 6 over 6i take 5. Alright, so that is an answer for z, except what we were asked is to express it in Cartesian form, so we haven't quite got that. So what I'm going to need to do is get this bottom line to go to a constant, so get rid of the imaginary thing. Now, if I write it in kind of the more standard form where we have real plus imaginary, so I'll do that for both top and bottom. What we know is if we want to get the bottom line to go to like a real number, all we need to do is multiply by the conjugate of what's on the bottom line. So that means that we just flip the sign on what's on the I. So this is going to go to negative 6i. And so that we keep this equal, we want to multiply by the same thing on the top line, because they cancel out with each other, and it's just like multiplying by 1, which of course does nothing. So let's expand this out. Okay, again we've got all these brackets around it to do that multiplication. So we're going to get 6 times negative 5, which is negative 30, and then 6 times negative 6, so negative 36. 7i times negative 5 is negative 35i, and then we've got, this is going to become negative 42i squared. Now we do the same thing on the bottom line, so negative 5 times negative 5 is 25, Negative 5 times negative 6 is going to give us positive 30i. These ones are going to give us negative 30i, and then this is going to give us negative 36i squared. Alright, continuing. So we know that I squared is going to go to negative 1. I'll put these together at the same time. So that's going to become negative 71. And this is negative 1. So negative 1 times negative 42 is going to give us positive 42. On the bottom line here, what we're going to find is that these cancel with each other. So plus 30i minus 30i, they both disappear. And we're left with 25, and this is, again, we can replace I squared with negative 1. So negative 1 times negative 36 is going to give us positive 36. So on the top line here, we can now join some stuff. So that's going to go to 12, and it's minus 71i. And the bottom line we've now got as a constant. So putting that together, it's 61. So the final step is just to express it in Cartesian form. So we just need to separate it into the real and imaginary part. So we're going to get 12 over 61 for the real part, minus 71 over 61 for the imaginary. So that is our final answer to this question.